In this lesson, we'll learn how to limit component motion. After completing this lesson, you'll be able to set a joint limit. With all the joints applied to our assembly, we now want to talk about limiting their motion. Now, in most cases, when you are trying to replicate mechanical motion inside of a CAD environment, you need to make use of digital limitations. Now, in reality, we could have physical limitations, and we can actually apply contact sets here to limit physical motion. But right now, we want to talk about limiting joints and how much they can move. So if we expand the joints folder, we have Rev3, which is the revolute joint we added between the bottom servo, the green servo, and the red servo. And this is going to give us our panning ability of the camera. If we right-click on Rev3, you can see all the available options. Drive joints, edit joint limits, lock, which will keep it from moving, suppress, animate joint, and animate model. So what we'd like to do is edit the joint limit. Now our specific joint is a revolute, which is only 1 degree of freedom. It's only allowed to revolve around an axis. If we had a cylindrical joint where we could rotate and translate along an axis, then we would have the available option to change this dropdown to limit both rotation and translation. And in this case, we just have one, but that's why there's a drop-down box here. So we want to have a minimum and a maximum. We also want to give it a rest value. So we're going to do the minimum of minus 30 degrees, and we'll do a maximum of 30 degrees, and the rest will be directly in the center. So we can animate that, go left and right 30 degrees, and we're going to say OK. So now if we look at this from the top view, the red servo is only allowed to move 30 degrees in each direction. At 30 degrees, it stops and it keeps it from traveling any farther. So this is, again, it's a great way for us to explore creating digital limitations that in the real world would potentially be a physical stop or some other geometry that would keep it from moving. A digital limitation like this would be a programmed limitation on the servo. And this is something that we're going to do in our flight controller when we build and we set up our model. But in this case, we're using that limitation digitally to make sure that we're not exceeding the travel. Let's go ahead and set the joint limits for Rev4. Now in this case, this is going to be the distance the camera can move up and down. We're going to have a minimum and a maximum, and let's set the minimum to minus 45 degrees, and you can see that that's rotating down. We'll set the maximum to 45 degrees, and we'll put the rest position right in the middle. Now if we animate this, it's going to go up and down, and you notice that there are some physical limitations. If we go to a front view and we rotate the camera up, you can see there's a point where the camera actually contacts solid geometry. Now in this specific case and in the real world, the camera I have used, the Fat Shark 700 TBL camera, I've actually cut and modified to match this shape. It had a third rib here and I used it to create some clearance to the point where we can rotate up a certain amount. You can also see as we rotate down, there is a physical limitation to where it hits this geometry. Now because we have a rest programmed in here, anytime I let go of this component, it'll snap back to that position. So this is pretty handy because it allows it to keep it in that same location without having to capture the position. With the joint limits applied, let's go ahead and save the file so we can move on to the next step.